Okay, so today we'll see introduction, like what is DNS, DNS overview and types of DNS. Like we have some types like authoritative DNS server. What is authoritative DNS servers? What is non-authoritative DNS servers? Then what is recursive DNS server? We'll see the types. Then we'll see little bit overview of NS lookup and dig utility. And then we'll try to perform this lab BIG-IP DNS as a recursive. Okay, in our lab. So this is the agenda for today. So this will be our course, guys. We'll see DNS overview, review and deployment, BIG-IP DNS services, uh, global server load balancing. Global server load balancing is like, for example, we have two data center. For example, this is your India data center. This is your maybe US data centers. And same application. Just consider Facebook www.facebook.coms. It is hosted on both the data centers. So where it is hosted behind our LTM boxes. So on same data center, we can deploy our DTM here. Just consider. And if anyone try to access the applications, DTM is going to be identified with the help of the user geolocations. For example, see people trying to access www.facebook.com from India. So if a DNS is going to be send that traffic to the India web, which is created on the LTM boxes. And then user will start communicating with that web, and there are facebook.com application server hosted behind our LTM box. So we don't need to focus anything LTM because we have already covered LTM. From DNS perspective, just consider if anyone try to do www.facebook.com, traffic come to the DNS, right? Just consider from local DNS perspective. DNS is going to be give the IP address. Similar if DNS will give the IP address to the people, and then people will start communicating with that applications with the help of IP address. Okay, so that is called global server load balancing. Data center and server. Data center is kinds of logical container. So there is one terminology in F5 DNS like data center, DNS virtual server, and then DNS pool and wide IP. We'll see all the things. Before that, if you guys want to do kinds of certifications, so which I'm going to do in futures, like F5 DNS. So this is the code, like code is for DNS code is 302. Okay, 302. So we can't directly give 302 exam. Okay, if you want to give 302, first we need to pass 101, 101, 201, then 301A and B. So this is the hierarchy in F5. We can't directly, jump to the F5 DNS certification. So these are the feature like secure DNS critical. So one thing's good in F5 DNS is it has a feature called DNS safe. We'll see in the lab. This is the
So yeah,
this will be.
one thing, just let me ask you something, the basic one.
Uh-huh.
Actually, that as we discussed, maybe the box is the same one, like it's like a big IP, then we need to purchase the license, right, for the DNS. Is it like this?
No, once we purchase
I
license,
mean,
one
DNS box is totally different or the same way, same devices actually.
see, it depends upon the requirement, but once we license your box, we are able to use all the features like DNS, LTM, everything. But what happened in the company, we keep A5 DNS as a separate device, okay, and LTM as a separate device. So on A5 DNS box, we only enable DNS module, okay, and that will be separate. We keep in that separate data centers. But in lab environment, we can use like same box as a LTM and DNS both. That is possible. But in company, we keep as separate. Okay, that is the recommended one. But once we enable the license, we are eligible to enable all the module like LTM, DNS on the same box.
Okay, understood. Yes.
So APAP DNS has some important features, guys, like DNS check. We'll see this is the last. This will be our last lecture. DNS check we'll see. It is going to be how it is going to be protect from the caching kinds of attacks. If anyone trying to do some mitigation in the middle for the DNS query, so DNS check is going to be have that. So you see superior DNS performance, DNS security, we have reporting and analytics, global server load balancing features available. It is going to be monitors. One more thing important in F5 DNS is, let me take the pen. For examples, we have two virtual server in the VIP. In F5 DNS, we have concept called wide IP. Wide IP nothing but FQDN. Okay. I'm going to explain in after some times. Wide IP nothing but FQDN. For examples, we have created FQDN for www.example.com. So if anyone try to do NS lookup to www.example.com, that traffic come to the F5 DNS. It is going to be check, okay, either in wide IP configure for that. Yes. Let's consider we have wide IP configure for FQDN like www.example.com. Then it is going to check, okay, how many pools in that wide IP? Pool is nothing but our virtual server IP address which we created on the LTM box. For example, we have two virtual server called inside the wide IP pool. So F5 DNS is going to be give any one IP to the client, and client will start communicating with that IP. Okay, and if this for example this is down, so this is the beauty of DNS. It is not going to be send the DNS traffic. It is not going to send this VIP IP to the client because it is already down. So it is only going to be sent to the active one. This feature is not available in local DNS, like whatever legacy DNS we are using in the company. But in F5 DNS, we can load balance the traffic and we can monitor the backend virtual server. If they are down, F5 DNS is not going to send the traffic to that VIP. So this is the good things in F5 DNS, but this feature is not available in local DNS. Okay. Now come to this. So why DNS is required? Like, could you guys keep your point here? Like why DNS is required? Just means something from your perspective, whatever you know. Why DNS is required in the company or anywhere? So answer is simple answer, you guys. If you want to go on the internet, we can't go without DNS. It is simple and short. Okay, it is very simple and short. For example, if you want to do www.facebook.com, I'm accessing www.facebook.com, and if I'm not resolving the any IP of facebook.com, then I can't access facebook.com, right? So that is the reason DNS is required. So if you want to access any application on the internet, DNS is required because computer never communicate with the help of FQDN. Computer always communicate with the help of IP address. Correct. So the domain name system is a hierarchical and decentralized naming system used to identify computer services and other resources reachable through the internet or other internet protocols, that is IP networks. Okay, just consider this PC. If you want to go, this PC want to go on the internet to access google.com, facebook.com, like some other applications. So what this PC is going to be send the DNS request to its DNS server, whatever configure for this PC. And that DNS server is going to provide the IP address, and then this client is going to be communicate with facebook.com, maybe youtube.com, or maybe yahoo.com, just for examples. So that is the reason DNS is required. Without DNS, we can't go and we can't communicate. So very, very important to understand.
See, actually, one more thing, like when we are hosting the DNS server, does it require them in the company? I am not sure. See, usually when we are purchasing the public IP address, DNS, it's managing by the service provider, right? They are giving the portal, we are entering the IP address over there, and the name resolution also will be putting over there, right? So we are just sending the traffic to the service provider. So why this box is required then?
Yeah, I'm coming to that point. So we have, we generally in company, we keep our local DNS, right? First. Company has separate DNS, and that is managed by the DNS teams in the company. And if this DNS has not the details, then we'll see, and after some times, how DNS work. So like we have concept like root server, top level domain server, then authoritative DNS servers. So whatever you are telling, for example, we have buy something, your domain, like example.coms, we need to entry that on GoDaddy or maybe from any providers, any registrar. So without entry, without adding entry there, we can't access that website globally. So every company has the design, like first we keep our local DNS just for the speed, or for example 10 people are accessing facebook.com. So every time a process is happening to go to the root server, top level domain server, authoritative DNS server, then IP will come to the local DNS. Local DNS will provide the IP to the client. So we keep our local DNS so that it is going to be maintain the caches in their records. So if same traffic coming again, it is going to be give the IP from its cache itself. Okay. So that is the reason we keep our first local DNS, and then local DNS is not resolve that query, then that will go to the as per the hierarchy like root, top level, authoritative, right?
Local DNS means whatever the applications we are hosting internally. So, like suppose the one company is internal, there are a lot of internal applications. So usually there are the two way, right? Where if we want to host any kind of application, we have created the virtual server and given the IP. That IP we can enter in the DNS server. I mean, not the DNS server, Active Directory with the host name, name resolution, and the people can access through that server through the since the AD is you know integrated, then the name resolution will be happen over there, right? So again, why the DNS server is required in the company itself, like within the local DNS? Is it any kind of I'm just asking the frankly.
No. Local DNS, see, for examples, let me explain. For this is my laptop. This is my laptop. If you run this ipconfig/help, what is the DNS server? DNS server is 192.168. This is my Wi-Fi router. So Wi-Fi router is acting as a local DNS. So if anything I'm accessing on this machine, it is going to be the local DNS first. From there, it will go to the actual server where actual application is binded. For example, facebook.com server. So, but first request will go to the local DNS. Okay, it depends upon your company design, like how we have configured your DNS. Okay, it totally depends upon design to design, infra to infra. But every company we keep first our personal DNS and like local DNS server, which managed by organization itself. And then if that DNS is not resolve the entry, then it will go to the public DNS server. In short, I can tell. So that is the reason first we keep our separate DNS server. But yes, whatever you are telling, first times query will go to the that server where actual IP is there. And once IP will receive to this server, it is going to maintain its cache. Okay. I hope you understand the point. Otherwise, we'll see here, how local DNS work and what is the purpose. Then it will be clear for you. Okay, just consider here.
Yeah, suppose like the what you call the existing DNS server should have the communication to the local DNS as well as the external DNS. I mean, in
Local,
internet
local.
transfer.
What you are thinking about local DNS server? Local DNS server is the server that is managed by organizations. So I am indicating that local DNS server. Local DNS server is your company DNS servers. So for example, if you are accessing any website in your company, we don't directly give any external and public DNS server IP on your laptop, right? As per the security design, as per the infra design, we generally keep our company DNS configured to every people's in the company, right? Every people or laptops. So that is the standard design. We can't directly give that DNS server IP where that application is hosted, right? This is not the standard design. So local DNS is just understand your company DNS server. So if anyone try to access any application in the company as per design, that traffic will go to your local DNS that is managed by your company. And if that DNS server has not the record of that applications, then it is going to be follow this process. This is the standard things happen in the backend itself. Okay, we don't need to do
Okay,
anything.
So come, so we can say like it's kind of protection. So like in even as well as internal or external DNS, right? So like in the flow, like uh, I'm making the flow. Suppose I want to access some kind of internet server. First of all, the internet server, then it will come to first it will hit on the DNS server, which is the F5 DNS. Then it will go to the virtual server. From the virtual server, it will be going to the actual server. So there will be different. It will, nobody doesn't know what is the real IP on the server, right? This is the idea maybe behind on it.
Yes. So right now we are just understanding just the DNS concept. We are not coming yet for F5 DNS. So we are just understanding how DNS work. So this
Okay,
is the
okay,
actual concept. This is not F5 related.
okay,
F5
fine.
will come later. So this is normal DNS concept. Just forget sometime for sometimes about F5 DNS.
Okay,
Just
okay.
consider like how uh, you know uh, DNS work. Normal DNS. We don't need to focus here F5 DNS. Just consider normal DNS. After sometimes, why this is required, guys? If you don't know like how DNS work, then how we can understand the other perspective, other things, right? So that is the important. First, we need to understand DNS, basic DNS, like how DNS work, right? Once we understand that, then we'll jump on the actual content, actual F5 things, right? So that is the reason I'm
Okay,
explaining
okay,
first
okay,
normal
okay,
DNS.
okay. Okay, understand, Sudhir, understand. Yeah,
Yeah,
go, please go
yeah,
ahead. Yes.
yeah. Okay. So just 1 minute. And one more thing, before you before starting any theory, I always suggest to read the PK file always. For example, DNS cloud server. I'm not going to take much time here, but I'm going to explain. I just want to give depth overview, guys, so that you can um, do in your free times. So first, always try to understand some PK file related to DNS, or if you want to be expert kinds of things in any protocol, to try to read that PK for that purpose. So this is the domain name systems like DNS. PK. This is I have it is available on CloudStar. So we can read it, in your free times. Like what is the first packet? This is the source. This is the destinations, and source is queuing for this FQDN, and then DNS server is going to be respond the IP of this, and then this client will start communicating with that IP. So try to in few free times we try to just read. The pcaps like one by one, like what is the query, what is the response. For example, this is the second packet, and and this is the type. This is the mention of types. So we'll see after some times how many types. And this is the first packet. This is not fully packet, but we'll do our own capture on our laptop. Where is the IP address? Just 1 minute. We'll see some other capture. Let's see this one. Okay, so this is the key one. Source is trying to like this is just URL, and this let's try to open this package. Where is the ID? I'm trying to find the IP address. It is not there. No problem. We'll focus here later, and we'll do our capture itself. So just start like how DNS, normal DNS works. For example, this is your PC. This is the people's, maybe your PC, your laptop, and we are trying to access, for example, just consider download.beta.example.com. This is the website you are trying to access first time in your PC. Forget about API DNS here. Just focus on the concept of normal DNS. So when you are trying to access this application download.beta.example.com, that request come to the your local DNS. Like in my PC, this is the DNS. So that traffic will come to the DNS. If you run this command ipconfig /display DNS. So there are so many caches already stored in this local DNS. That is router, Wi-Fi routers, home Wi-Fi routers, which is also acting as a DNS server sales. Okay. So that request will go to your DNS server, which is configured for your laptops. Okay, which is configured for your laptops. This DNS server is going to be check its entry, like that entry is available in its cache files, or maybe if there is entry locally for that download.beta.example.com. Sometimes what happens, guys, if for example, if there are 15 URL is there and it is not need to allow publicly, and that is only required to handle or access through company employee, and there are 5-10 people as there. So what happens, sometimes we do locally host configuration, like if you go on the C and there are some path where we can manually configure, for example, facebook.com, we can manually configure some IP here, and youtube.com, we manually configure some IP here. So if anyone from your company is trying to access, request go to the local DNS, it is going to be check its host file for that URL. Then it is going to be check the cache file for that URL. Okay, there is an entry for that. If yes, it is going to provide the IP to the client, and client will start communicating with that IP address. Okay, so just consider user is trying first time to facebook.com and that IP is not available to local DNS server because actual that IP is not hosted on local DNS server, not binded on local DNS servers. So what is the flow? Then that will go to the root server. Root server is guys dot, indicate from dot. For example, www.facebook.com. So after com, there is concept called dot. It will not visible kinds of thing, but just understand from the theory perspective. So that request to the root server. And in F5, in DNS, there are two types of query: recursive query and iterative query. I'm going to explain in details what is recursive query and iterative query. First, try to focus here. That request go to root server. It is going to tell I need IP address of download.beta.example.com. So root server is going to tell, okay, I don't know, but I can suggest you to go to the .com server that is called top level domain server. So there is concept dot is root, .com, .org, that is the top level domain servers. Once you buy your domain, it will be from any registrar, for example, GoDaddy and others. Okay, then this local DNS is going to be ask the IP address from the .com, that is top level domain server. I need the IP address of download.beta.example.com. Then top level domain server is going to tell, okay, I don't know the IP, but I will suggest to go to the authoritative server, that is example.com. Then again, this local DNS server is going to be communicate for the IP. I need IP address to the download.beta.example.com. Then it is going to, I don't know, but try to asking the .com authoritative servers. So this is the beta.example.com. This is the authoritative server where actual IP is hosted for the download.beta.example.com. Okay. Then this local server is going to be start communicating with the authoritative DNS servers. We can say like beta.example authoritative DNS server where the entry for download.beta.example.com is there. So it is going to tell I am authorized for beta.example.coms and I know the IP address of that server. So once this server, authoritative DNS server, is going to give the IP address of the beta.example.com, then it is going to be received to the local DNS server, and local DNS server is going to maintain its cache, and then it is going to send that IPs to the client, and then client will start communicating with that IP. Okay, so this is the normal overflow for any DNS query in the company, guys, and these things happen in the backend very quickly, but we need to understand the concept from the DNS perspective. Let me know if you have any questions.
Yeah, so far is good. Yeah.
Yeah. One more thing, very important, before coming to this diagram, because this diagrams and this diagram both are same, but this is quite good from the understanding perspective. That is the reason I have kept here for you guys. Because I my goal is to teach on the perspective like no one can know about DNS simples. I'm trying to explain first time. So from that perspective, I keep everything. So in F5, not in F5, just consider in F5 there are two type of query: recursive query and iterative query. So let me
Yes,
first,
yes, sir.
yeah,
This question is very important. Some interviewer asking what is the recursive and
yes,
iterative DNS query.
yes.
So
Coming
can
to
you?
that, yeah. So before explaining this diagram, coming to the query first. So this is your PC, this is your laptop, this is your local DNS server. Forget about F5 DNS here. This is your local DNS server configure in your environment. Okay, and this is your machine, and we are trying to access www.facebook.com. Okay, so that request will come to the local DNS server, which is configured to this PC. Okay, it is going to ask, okay, I need IP address of www.facebook.com. Okay, so just focus on the recursive here. Recursive means whatever things I have requested to you, you are directly providing that detail to me. That is called recursive. I don't know how many process we have follow going forward, how many process we have followed to get that IP address. I don't know. I have requested the IP of facebook.com and we have given IP to me to www.facebook.com. That is called recursive. Iterative means I have requested the IP address of facebook.coms. You don't give IP address of facebook.com, but you have given me some clue. Okay, if you want IP address of facebook.com, please go to that server. Means I'm not giving directly IP address of facebook.com, but I am providing some clue to you, some suggestion to you. Please go that place. Please go that place. That is called iterative. Okay. So in anyone asking in the interview, always tell like your client and local DNS every times when client requests anything to the local DNS, that is always recursive query. When local DNS is trying to communicate to root, top level, authoritative DNS server, that is always happen as a iterative. Okay, so this is the difference between recursive and iterative. In simple and short, I'm going to explain again. Recursive means I have requested some things we have given directly to me. In iterative, I have requested something, but you have not given that details, but we have provided some suggestion and clue to go that place. That is called iterative. Let me know if you have doubt.
Okay, suppose if they are given some what do you call the suggestions, then it will be changed and automatically. Then I mean it
Automatically.
will be, yeah, it will go there, and from there it will go to somewhere.
Yes,
Is it like this?
yes, automatically.
Okay. So how we know that it's based on that? Because as a customer, as a user, doesn't know anything, we can, and how we can understand this is the cursive and iterative.
see this part we can't see. There is no any mechanism to see, but we need to understand. For example, if you are, this is my, just consider this is my domain. So from where I buy it, so from some registrar like GoDaddy and all, where we need to maintain our, for examples, just consider here, local, yeah. So when we create DNS server, there is concept that name server. Okay. So that name server entry we mention on our start. Okay. So when any traffic come to the local DNS, then it is going to be sent to the root. So once we do the entry on your registrar, it is going to be follow the mechanism like that. We don't need to do anything like how recursive look like, how iterative look like. But as a F5 administrator, as a F5 DNS administrator, we should aware the query, like what is recursive, what is iterative. We can't visible all the things, but we need to understand the concept in the backend.
Okay.
Raman, it is clear for you also?
Yes, yes. Acha, Surya, what is the area code and CNAME?
Yes. I'm coming to that. We'll see all the things. Okay, whatever query in your mind, guys, everything I'm going to cover here. Not only a perspective. That is the reason I started from the basic things before coming to the F5, because F5 DNS is very simple and short. We don't need to focus much things. I'm going to cover all the things whatever required from company perspective. Rest thing, once you start doing working in your company, in your environment, maybe new company. So at that times we don't feel any kinds of problem. Okay, I don't know that part. We just need to do little bit brush up and we can start working handling that part. Okay, because once we enter in the production, once we start working on the production, then we know the actual things, right? Everyone aware. But if you know the foundations, if you know the basic, if you know that at least 60-70% of the work, like how that concept work, then we can start easily handling in your business. Okay, so this is also for how DNS work. So just consider local DNS. If anyone try to f5.coms, so it is going to be check local DNS caches. How we can check that? IP configs like display DNS, which I have shown you guys. Then that request will go to the local DNS servers as a recursive. Recursive means this PC is telling to this server, I need IP address f5.coms. Okay, then this local DNS is going to be sent to that query to the root server. Okay, root DNS servers. That will be the iterative. Iterative means it is not important like that IP, that URL IP is hosted on that root DNS server. In India, like there are 13 or 15, I'm not 100% sure. We have 13 or 15 root server. If you do Google, you will get the details. Then this root server is going to be give some clue. Okay, I don't know IP, but please try to reach to the .com server, that is top level domain server. Then this local DNS try to reach to this. Then it is going to, I don't know, but I'm going to be give the clue. So try to reach to the f5.com authoritative name servers, and then request to come to that server. This server has actual IP address f5.com. Then this server is going to provide the IP address f5.com, that is a record, to this local DNS. Local DNS server is going to maintain this IP in its cache, and then it is going to be provided to the client. Okay, when next time, this try to understand, guys, very, very important. When next time another people is trying to access f5.com, because these people is already, this PC is already try to access f5.com, and all the process happen in the backend, and IP already maintain its cache, local DNS cache. So when another times three, 4 person is trying to access same application, that traffic come to the local DNS server and it already in its cache, it is going to provide IP right away. It is not going to follow all the process again. So that is the importance of the cache. Okay. Perfect. So there are some DNS terminology, guys, like domain names, like f5.coms. So .com is the we can say like top levels, f5.com means this domain is acquired by the f5. This is owned by the f5. Okay. Subdomain is, for example, we have f5.coms, and before that we are putting something like support.f5.com. That is called subdomain. Okay. So this is the DNS hierarchy. We have root and then top level, second level domain and subdomains. So root means dot, top level like .com, .org, some things. And then we have second level domain, for example, f5.com, youtube.com, facebook.com. Okay. So first name indicate that domain is owned by that company. For example, f5.com. So that domain is owned by f5 company, facebook.com, that domain is owned by Facebook company, youtube.com, that is owned by the YouTube company. Subdomains like www.facebook.com, www.youtube.com. So that is called subdomain. This is the DNS hierarchy. Okay. We have like DNS sub, in DNS we have concept like DNS lookup, like we'll see later, DNS lookups. And then we have name server. So name server is nothing but, guys, a store information about a zone. Zone is what is zone in DNS? Zone is nothing but your domain. For example, a5.com. That is generally zone. Don't get confused. Zone means your domains. So there are two types of name server, primary and secondary. Every zone has its data stored on both primary and secondary name servers. For example, if anyone tried to access f5.coms, so name server has the details of the f5.coms. Okay. So in name server, just consider a store information about your domain. It is simple and short. If anyone asks what is name server is the server which is going to be store the information of our domain, facebook.com, youtube.com, f5.com. Okay. Then we have now come to your point. What is A records? So A records is nothing but, for example, we have www.facebook.com and we have binded this with IP address 10.10.10.10.10. So we are directly binding this URL to any IP that is called A records. And what is 4 times A? That is for the IP version 6. The same thing, but this is for IP version 4, this is for IP version 6. So that is called A record. So if you are binding any IP to your actual applications, that is called A record. Okay. Then we have CNAME. CNAME is nothing but your canonical name, or CNAME records link an alias name to another canonical domain name. CNAME record must always point to another domain name, never directly to an IP address. For instance, alias.example.com might link to example.com. Let me explain with the help of example, because so many guys have some confusions about CNAME. CNAME is, guys, just the canonical name. For example, this is your actual application, example.coms, but behalf of that we can create some canonical name. Okay, alias.example.coms. So if anyone try to, just understand here, if anyone try to access alias.example.coms, actual content is handled by this, but behalf of this CNAME is working. Just understand here. So we are creating canonical to the actual, like on behalf of the actual domain, actual code in short. Why we create CNAME, guys? You can ask question, why CNAME is required? CNAME is required sometimes if you want to divert your traffic in the productions. Divert means, for example, if you want someone trying to access www.facebook.com, that traffic first reach to our web. Okay. And after web, we need to do some inspection on the web because of some attack kinds of things. And after web, then that traffic will come to the actual server where that application is hosted. Okay, for that we create canonical name here. So if anyone trying to access actual application, that traffic will come to the web, and from web it will come to the actual server where that application is hosted. So for that purpose, we created canonical name, CNAME. Okay, and maybe it depends vary to vary, but I am telling one of the example which in my current company setup. So till now, I hope you guys are getting the points.
Yeah, it's fine. So there one more thing, like when we are entering the air record, is it it's not required to put the CNAME also. There are like air record is enough, or
Yes.
CNAME is like
No.
anyone
Different.
we can
Different.
enter over there, right?
Yeah. Yes. Correct. You are right. A record, we don't need, then we don't need to put CNAME there. CNAME is totally different than a. Okay. So then we have NS record, same thing, name server, whatever I explained. So name server record determine which server will communicate DNS information for a domain. Generally, we will have primary and secondary name server. So name server is just understand, guys. Name server has the details of the zone. For example, if you are trying to access facebook.com, so name server will provide you, okay, which DNS server I need to go to find the IP address of the f5.com or facebook.com. So it is maintain the record of the zone. It is very simple and short. MX record is used for mailing purpose, mail server purpose, guys. So mail exchange record directly email to server for a domain. So multiple MX record can be defined for a domain, each with a different priority where the lowest number is the highest priority. So if mail can't be delivered using the first priority record, the secondary priority record is used and so on. So MX is kind of related to the mail servers. So some part will be clear once we do some um, examples. So for example, we have mail server, just consider google.mail.com, for example. So that mail server has some record. Inside that, there are some multiple record that is called MX records. It is related to the mail actions. Okay, there is one demerit in a local DNS. Now we are slowly going to the F5 DNS. Okay, why I explain all the things so that you guys can relate all the things with the F5 DNS. Okay, that is the reason it is important to understand local and normal DNS concept first. See, in normal DNS, we don't have high availability concept. A DNS cannot determine if site is up or even exit. For example, this is your local PC, this is your local DNS, normal DNS. And if you're trying to access facebook.coms and just consider.
Surya, you can continue the session. I'm just going down. I will be back in 5 minutes. Okay, you can continue.
Okay, yeah, yes, sure. So, like in local DNS, if anything goes down with that applications, uh, local DNS has not the visibility. Okay, local DNS is not going to monitor it. So these are the demerit in local DNS. Okay, only support round robin node, but DNS will continue to resolve to a site even the site is down. So in case of local DNS, for example, we have two sites, just consider, and on two sites, same application is hosted, facebook.com. And if this site is goes down, still this local DNS is not the visibility, and it is going to be send the request to this site itself. It is not going to be monitor the health. So these are the features not available in local DNS. Okay, but these features is available in the F5 DNS. Okay. Also, it is not going to be mitigate from the attack like DDoS attack, but in F5 DNS, we have the concept like DNS check. So with the help of that, we can mitigate the attacks. Okay. Okay, so in case of A5 DNS, BIG-IP DNS direct users to the nearest data center that will provide the best application experience. So this is the beauty of A5 DNS. It is going to be uh, provide the IP address based on the user locations. Okay. So for example, if you are trying to access facebook.com, it is going to be provide the facebook.com IP address near to your locations. Okay. For example, facebook.com is hosted on two data center, India data center and US data center. And you are trying to access facebook.com from India data center. So it is going to provide the IP address of the India data centers from India data centers. So while doing that, it is kind of ensure the speed and good experience, easy, easy and easy to resolve, and user will be don't face any slowness kinds of things. So this ensure your distributed appliances are always fast and available. Okay, so this is the uh, actual meaning, and this is the benefits of the fabric. So BIG-IP DNS employ a range of global load balancing methods and intelligent monitoring specific to each applications and each user. It also routes traffic according to your business policies and current networks and user conditions. Okay, it is going to choose the closest to best performing data center. Data center is nothing but a logical container. For example, we have one LTM, one GTM, one LTM, one GTM, one LTM. So we can put, okay, this GTM is the part of data center India. This LTM is the part of data center US, just for example. So data center is just the logical container inside that we are putting our devices. Okay. Then continuously monitors application availability. Then the routes traffic based on the business logic to available applications. Okay. So traditional way to increase DNS capacity, add more DNS servers, load balance between them, only 75K RPS and a lot of, and in case of A5, it is going to be DNS zone transfer for auth DNS, hyperscale up to 200% with rapid response, and up to 200 premium DNS server, 500 performance of bind. So there are so many good features available in A5 DNS. We can use as a zone transfer concept. Zone transfer concept, for example, if query come to the A5 DNS, and if the entry is not in A5 DNS, then that request will go to the peer, we can say like peer zone, where the actual application is hosted, and then A5 is going to take the query from that DNS server. It is going to maintain its cache, and it's going to send to the client. So some things we'll see in the lab. This part is very, very important. Okay. If you know this, then this is the actual DNS. That's it. These things we'll cover later. But these things will come later. So for today theory, we need to come here, and then we'll see one lab. So Haris is back. Ramanji, are you there?
Yes, Surya.
Okay, so मैं 1-2 मिनट वेट करता हूँ because this part is important from DNS perspective, F5 DNS. And once Hari is back, then हम start करते हैं. So this is the packet flow of F5 DNS. So अगर ये आ गया मतलब F5 DNS खत्म. You can easily understand the flow. Yes, so we have seen like DNS overview in types of DNS. So types of DNS, this is the part we'll see, and NS lookup and dig utility, and we'll see this lab. So this is the today agenda. Let me pause the recording for sometimes. Okay, so this part is very important. Then we'll see some more theory, and then we'll do one lab, and then we'll complete for our today. This is very important to understand. Okay, so if you know this flow means you can implement a F5 that is the important thing. So this is the concept. This is the packet flow concept thing in a F5. So let me explain and try to focus here, guys, and we can ask any questions. So if any DNS query come to the F5 DNS server, it is going to be checked the name is wide IP. Wide IP means FQDN. Wide IP means FQDN. Just consider we have created FQDN for www.example.com. Okay. For example, if anyone is trying to get the IP address of www.example.com, just understand like that. That query come to the F5 DNS. It is going to be check. Okay, is there any wide IP configured for that? Is there any FQDN configured for that? Yes. How many pool in that wide IP? Let's consider pool means virtual server IP address, which is created on the LTM boxes. So for example, there is pool configure inside the wide IP. It is going to be provide the IP address from that pool to the client. And it is going to be provided to the nearest location, nearest data center as per the user. We can select user presence. Like it depends like from where user is trying to access. Okay, and it is going to be intelligently resolve that IP address and provide the IP address to users. Just consider there is no any wide IP configure, there is no any FQDN configure for that URL. Then it is going to be checked either in DNS express zone is there. What is DNS express zone is there, guys? DNS express zone is kind of, in that case, F5 will act as a secondary DNS server. And maybe for primary DNS server, we have some local DNS server. And all the details is fetched from the local DNS server to the F5 DNS server. So it is going to be check, okay, either in DNS express zone is configured for that URL. If yes, the entry is there, that details is fetched to F5 DNS. Yes, it is going to provide the IP address from that. Okay, just consider DNS express zone also not configured. Then it is going to be check its own cache. Okay, is there any cache maintained for that application? Like, is there any IP available in its F5 DNS cache itself? If yes, it is going to provide the IP address to the client. Just consider cache is also not available. Then you have resolving cache defines. Resolving cache means something like we have kinds of binded some application with some IP. DNS lookup and cache response. If yes, it is going to provide the IP address. If not, it is going to be see, okay, is there any pool configure on F5 DNS itself? Like we have listener. Listener means guys, just consider it as a VIP IP. We'll see in the lab, then it will be more clear for you. Don't worry about it. So if anyone talking about listener, that is the VIP similar like our LTM VIP. Okay. So VIP listener is basically virtual IP and it will act as a DNS server. So local machine PC will configure listener IP as a DNS server IP. So if the IP is not available in resolving cache, not defined in resolving cache, then it is going to be check, okay, is there any listener has pool? Okay, inside listener we have configured any pool. Inside pool we generally keep the IP address of the application server. If yes, it is going to provide the IP address from that pool. If not, it is going to check, okay, DNS profile allow local bind. Like inside DNS profile, is there any entry for that applications? Yes, it is going to provide the IP address to that client. If just consider if there is no any DNS profile allowed for local bind, then it is going to listener, not a self IP, forward the server with listener IP address if response through BIG-IP cache. So just consider like if there is no any mechanisms to find IP address via this process, then F5P simply tell to the user, I don't have details of the IP address, and maybe we can see request timeout when we do the NS lookup or maybe dig commands. So this is the simple packet flow and the decision flow in F5 DNS. Here we can't see all the things in lab, but the important things we can see, for example, which is required, for example, like wide IP1, then we can see this one, and then we can see like this one, and so many things we can see. Some part we can't see, so don't worry about it. So this is the decision flow. Let me know if any questions. This will be more clear once we do in the lab, but this is the basic decision flow in F5 DNS.
That's fine. We can continue then.
Yeah. Okay, so so this is we'll cover later. So this is huge case of the following BIG-IP DNS feature: DNS Express, zone runners. We'll see lab for zone runner also. Then DNS feature, DNS cache, DNS load balancing algorithm, DNS persistent, DNS health monitoring. So these are the things. Now,
Surya, in company scenario, you can see I have Route 53 and public zone and private zone. So we are entering any name on Route 53, but that redirecting to our F5. So how it is going to that?
yeah, that will be in part of DNS express zone. Express zone means like the scene like A5 will act as a secondary DNS server, and some another server will act as a primary DNS server. So all the details, all the entry added in primary DNS server, it is going to be synced to the F5, and if this server is not able to provide the IP address and already that entry is synced in this DNS server, so it is going to provide IP to the client. But first approach is it is going to be check DNS express zone. It is going to fetch from the primary, and F5 will act as a secondary DNS server at that times. Okay, so now come to here. So we have seen like introduction, DNS overview, and types of DNS. So there are some types, guys. Authoritative DNS server. What is the meaning of authoritative DNS server? And then we'll see one lab. This is the tools NS lookup and dig. I'm pretty much sure you guys already know NS lookup. Dig is also similar, but in dig we can see some more informations the compare of NS lookup. But I'm going to explain all. Don't worry. So what is authoritative DNS server? Authoritative DNS server means an authoritative DNS server holds the original zone file for a domain. It is the final source of truth for DNS record like AMX, CNAME, TXT. For example, I have configured F5 DNS as authoritative DNS server means, for example, someone is trying to access facebook.com, youtube.com. That entry is already available in the F5 DNS itself. F5 DNS server don't need to carry from the root server, top level server, authoritative DNS server. So whatever I am requesting, it is already available on that server, means that server is working as a authoritative DNS server. Means that server has the actual file for domain, actual IP for that domains. So that is called authoritative DNS server. Means I am authorized for that applications. You are authorized for that application. That is called authoritative DNS server. Okay. So it is going to be a store and serve official DNS record, respond to query with authoritative answers, managed by domain owners or DNS hosting providers. So if you query for and it hold the zone file, it will respond authoritatively. Use case hosting DNS zone for website used by registered like cloud DNS provider and enterprise DNS infrastructure. So in simple and short, just understand what is authoritative means. I have requested something and whatever server is configured for example, local DNS server, we have given the IP of the F5 DNS listener IP, and that record is getting from that IP, that server itself. Means that server is authorized for that record. Non-authoritative means request come to me, but I don't have detail of that IP. I don't have record of that application. So I have requested from someone else, like top level, root, authoritative. That is called non-authoritative. I am not authorized for that record. Okay, so that is called non-authoritative DNS server. Means I am taking that detail from someone else. I don't have record of that application. Okay. Then we have recursive DNS server. Say recursive DNS server perform the full resolution process on behalf of the client. It queries multiple DNS server until it finds the final answers. So we are going to see this in the lab right now. Okay, recursive DNS server. In case of recursive DNS server, guys, F5 will act as a recursive DNS server. So, for example, if you want to access, for example, Facebook.coms or YouTube.coms, that request come to the F5 DNS server, and F5 DNS server is going to send that query to the some publicly valid available DNS server. For example, Google DNS server, Open DNS server, and it is going to be maintain the cache of that record. And when second time user is trying to access, it is going to provide the IP right away. So that is for recursive. And recursive concept I have already explained means whatever requested I have, whatever I am requesting, the IP address of any application, I need the IP address. I don't need clue. I don't need suggestion. Okay, so A5 DNS is working as a recursive DNS server. So whatever query will do, it is going to be provide the IP address of that query. It is not going to provide the suggestion and clue. And from where it is going to fetch the details? It is going to fetch the details from the Google DNS, Open DNS, and it is going to maintain its entry in the cache. Okay. It start the root server. It is going to be send the request to the root server, then top level domain server, then authoritative servers, and it is going to be cache response for future queries, often combined with caching functionality. So in case of recursive DNS server, it is going to be get the IP address from the top level, send the query for the root server, top level domain server, authoritative server, and once they get the IP address from authoritative DNS server, it is going to maintain its cache, and when next time user is trying to access that application, it is going to provide the IP address from its own cache. So that is called recursive DNS server. Okay. Then we have caching only DNS server. So a caching only DNS server does not perform recursion or holds on file. It's simply a stored DNS response. It receives and serves them from cache. And no zone authority, no recursions, only respond with cache data if available. So caching only data DNS server, its name indicated, guys. So it is going to provide the details from the cache. If no, it is not going to be provided. It's very simple and short. So why I explain these things? Because if you see this flow, this flow, guys, this flow, all the things, whatever I'm explaining, it is coming here. So once we know that concept, then we can easily understand this flow. That is the reason I'm explaining that part. Okay, so caching only means it is going to only provide the details, whatever it is in cache. It is not going to be send like the query to the root server, then top level server, top level domain server, then authoritative server, then get the IP address, then maintain its cache, send to the client. No. If it is available in its cache, it is going to provide, otherwise it is not going to provide. It's very simple and short. That is called caching only DNS server. Let me know if any question, guys, till now. In the difference between authoritative DNS server, non-authoritative DNS server, recursive DNS server, and caching only DNS server.
Yeah, it's okay. Fine.
Okay, perfect. Now, before lab, we'll see a little bit this about NSLOOKUP and dig. So dig is only, see, if you have the Linux machine, we don't need to install dig manually, but in Windows we can't run directly. We need to install it, and there are some process we need to follow. So you can watch. I will share one video. Through that we can install in your Windows machine. If you have Linux, you don't need to install dig. So for examples, this is our laptop.
Which command you enter here? Just want to see. What is the command?
Clear.
No. I
See,
mean, before that, just ipconfig only or something else?
ipconfig/display DNS.
Display DNS. Okay,
Yes,
okay. Yeah.
ipconfig/display DNS means it is going to be show all the record whatever it has already there, like it's kinds of cache. So this is our local DNS, and local DNS is maintaining all the records. So for example, next time if I am trying to access this www something, it is not going to be sent that query to the root server top level and top level domain server authority server. It is going to provide the IP because it already maintains in cache, its own cache. Okay, local DNS. For example, if you run dig here, for example, dig, it will not work here. Dig, for example, I am trying to query from Google DNS with the help of dig. I need the IP address of www.facebook.com. What will say? Dig window. Let's consider here NSLOOKUP. NSLOOKUP will work here. So once we do NSLOOKUP, I'm trying to do www.facebook.com. Let me close and again open it. If IP is not a facebook.com, then how you can access Facebook, right? Let's try some another application. www.youtube.com. We are typing correct URL. Just one minute, guys. Default gateway ipconfig/all. We have DNS server 192.168.1.1, and if you try to access here YouTube, we are accessing, right? So without IP, you can't access it. Very simple and short. Let's do like that. If you do the NSLOOKUP, and I'm pointing this server 192.168.1.1. And now we'll ask the IP address. Let's see. I want IP address of www.youtube.com. See, so now I get the IP address, but it is saying non-authoritative. Non-authoritative means 1.1 has not the record of youtube.com. It is taken from someone else. It is taken from someone else. That is called non-authoritative. Because if facebook.com, youtube.com is not hosted on our local DNS server. That is the reason local DNS server send query to the root server, then top level domain server, then authoritative, get the IT from that, maintains cache and send to the you. That is called non-authoritative. Okay, maybe we can try like www.facebook.com here. So now we get the IP address facebook.com, right? So this is how NS lookup commands work. NS lookup is basically used to find the IP from FQDN, IP to FQDN, vice versa, we can say. But in case of dig, we can see some little bit more. And dig is mostly used at the times of DNS troubleshootings. In case of dig, we can see like how many times our DNS server has taken to get the query. Like how much time it is taken to get the IP address. These types of details we can see in the dig. So don't worry, we'll see here once we do our lab. So let me just start the lab. Okay, so just forget these things. So because of license issue, I don't have much license, and nowadays F5 has changed the process to get the registrations. I am trying to use same key registration key for multiple lab. So we'll see. We'll try to enable this lab first, and if we come to and then we'll come to the like global server load balancing wide IP concept. Then we'll cover this lab, and same F5 DNS I will put here. Okay, and I will delete from here. Okay. So this lab is for the A5 will act as a recursive DNS server. Means this PC, when this user is trying to access textbook.com, that query come to the A5 DNS. A5 DNS is going to be sent to the that query to the root server, then top level, then authoritative server, and get the IP address from that, and is going to maintain its cache and then provide the details to the client. And for that, we'll configure the pool on F5 DNS. In pool, we'll configure our Google DNS server IP address and Open DNS server IP address. So if anyone trying to access facebook.com, that request come to the F5 DNS, send to the pool. Inside pool, we'll configure Google DNS IP and open server IP address. And from that server, it is going to fetch the details, and then it is going to be sent to the client. So that is called recursive. Recursive means whatever I have requested, I need the IP address of that application. It don't matter from where you are taking it, but I don't need clue. I don't need suggestion. I directly need IP address. That is called recursive. Okay, so this is the steps. Let me show here, and I'm going to share all the PDFs so you guys can go through it. So this is the types of DNS we already cover here. Authoritative, non-authoritative, authoritative, recursive DNS server, caching. Also, we are going to see the lab for this recursive DNS server. So this is the steps. So to create recursive DNS servers, first we need to create the monitor. So I have already created, but I'm going to delete and again create for you guys. So DNS monitor. So first we'll create one monitor for the DNS monitor, especially for monitor. And then we need to create the pool. Inside pool, we'll put Google DNS IP address and Open DNS server IP address. Pool is similar. Whatever pool we create in LTM, similar we create here also. So when anyone try to access facebook.com, maybe that details will be received from Google DNS or maybe Open DNS server, and then F5 is going to maintain its cache and send to the client. So this is the actual concept here. Then we need to create the cache. Okay, once we create cache, so that F5 will maintain the entry. Okay. Perfect. Then we'll create log publisher. Why we create log publisher? It is not mandatory, guys, log publisher. But we create, for example, we want to see the logs related to DNS queries, right? Response queries. So for that, we generally create log publisher. So log publisher, I think if you guys brush up the LTM concept, we have at the times of like our syslog, remote logging and syslog server, we have seen log publisher. The same things we'll do here. And then DNS logger. And then we need to create DNS profile. And inside DNS profile, we need to enable some setting like DNS caching, DNS cache name, and then logging whatever logging we have created. And then we need to create listener. Listener is just the VIP virtual IP. Okay, so just let me explain here. Um, this PC, this PC, 1 minute. This PC, On this PC, will create the DNS IP of the listener IP, whatever created on the F5 DNS, and will create on the same range IP address, whatever on this interface. For example, 192.168.1.126. So we can create 1.127, and that VIP IP will act as a DNS for this PC. So whatever listener IP we have created on the F5 DNS, that will work as a DNS for the client. Okay. So listener is just the VIP IP, virtual IP, similar like virtual IP which we created on the LTM box. So we in the LTM, what we created? We have created VIP, and if anyone trying to access that VIP, it will come to the F5, and F5 is going to be send the traffic to the all the backend server. Okay, the similar like in DNS also, listener means virtual IP. Okay, and gateway we can generally give the egress interface IP address, whatever we have created on the DNS, sorry, LTM. Similar for this PC, gateway will be this interface IP address, and DNS will be the virtual IP we have created as a listener on the F5 DNS. So when this is trying to access anything, that query go to the listener IP, and listener IP is going to be checked. Okay, is there any pool called? Is there any pool called? Okay, how many things in the pool? We have two IP address, 8.8.8 and then 9.9.9. Then this F5 DNS is going to do the query from this IP. I need the IP address of facebook.com. Then this is going to be replied to the F5 DNS. F5 DNS is going to reply to the client. So this is the mechanism behind this lab, guys. Let me know if any questions. I hope you guys are getting right.
It's fine. It's normal.
Yeah, and we can do some brush up in your free time, so it will be. And any doubt, we can comment anytime, ping in the group anytime. Okay, so we'll create listener, and listener, inside listener will create all whatever created on top. All the will do mapping here. Like for example, whatever pool we have created, the profile we have created, and auto map will use. So in SNAT we can auto map similar like LTM, and okay. So and then some TTL value modifying. It is not mandatory, but we can do. It depends upon the business to business. It depends upon totally design guide. So these things we can change. Minimum TTL time means TTL means after this time it is going to be flash that record. It is simple and short. So for example, minimum TTL is 432,000 second means till this time our DNS entry will be there for the facebook.coms in the F5 DNS, and after that it's going to be flash it. Okay, so that is the meaning of this like whatever cache TTL value. Then we'll try to do NS lookup, and we'll try to verify it. Okay, so let me show if we have access 192. One 192.168.137.08. Okay. Okay, so we'll try to follow the steps. How F5 will act as a recursive DNS server. First step to activate the module. So we have already done it, but I'm going to show you. If you come to the here resource provisioning. So if you want to act as a F5 DNS as a recursive DNS server, we need to enable the DNS, LTM and DNS both. Okay. So I have enabled two modules, LTM and DNS here. So this is the first step. If you want to configure a file acting as a recursive DNS server, that is the first step. Second step, git monitor. Okay, for DNS. Similar, when you go to local traffic monitors, I have created DNS. Let me show you. Let me delete this and then we create again. We delete this. It is going to say telling like it is already in use. So I need to delete from here one by one. If I delete this, then it will work. The listener I have deleted. Let me delete all the things whatever I configure, and I'm going to explain and show from beginning to you guys. So all the things related to DNS it will show here. All the things related to LTM it will show here. Okay, so let me first delete all the things so that I want to you guys can show from beginning. So
So yeah, one thing actually, GTM and DNS is the same one, right?
yes.
But
GTM is
earlier it
now
was,
called DNS.
sorry?
GTM is now called DNS.
Yeah.
Earlier here there was option on GTM here.
Yeah, okay.
Instead of DNS, it was GTM here. But when I
Okay.
started working on FF DNS, mostly DNS I have seen, but earlier it was showing GTM. Okay, so I have created profile, deleted profile, and every profile DNS and other DNS logging. Let me delete all the things so that I can show you. Okay. The virtual server also deleted. Tool, let me delete it. Yes. So okay, and rest thing will delete one by one. So okay, first step to create. I will share this so that we don't need to remember any steps. We just need to follow this step. Monitor, simple monitor. Come to the LTM monitors. Click create here. Okay. Now first let me delete it. It's already there. And earlier it was not deleting because it was called on the our listener. Let me just remove this. Close. So monitors create here, and we can give name here DNS monitors. Okay, and type we need to select DNS. Why creating DNS monitor? So that this is going to be monitor our DNS server, DNS pool. We can say like, okay, DNS server is there or not. If not, it is not. It is not going to be take the IP address from that DNS. We can say pool. Or in short, we can tell like if that in short I can tell, for example, there are two poll call and one pool is down. So it is not going to be send the query to the pool which is down. It is simple and short. So this is the DNS monitor. Keep all the setting as it is. Five and times query name. Maybe you can give query name. Give me anything. This is optional. f5.coms. Let me verify if anything is there. Type DNS name. Keep all the setting at default. Click finish. Configuration advanced. Just 1 minute, guys. Someone is on my door. Okay, in configurations, we'll keep like advanced and interval 5 seconds up. These things will be the default one. And yeah, so now we are good to go. So we can finish it. So we have created DNS monitoring. What is the next step? Next step to create the pool. So creating pool is the same things whatever we do in the local traffic. See, so these things we need to follow when your F5 is acting as a recursive DNS server, okay, not in GSLB. GSLB lab will be different. We'll see in our upcoming sessions. Come to the pool, create here pool, and we can give name here, for example, DNS pool, and see whatever monitor we have created. See, now we need to select that. Okay, that's very simple and short. So why that is the reason we have created first monitor here, DNS monitor especially. Load balancing method round robin. What is the node? Use Open DNS server. Open DNS server IP is 999. Everyone aware, right? It is work on the port 53. Add it. Second is Google DNS. IP address of Google DNS is this one, right? We have added it. Then finish it. Okay, one more things. Yeah, this is up. Fines. One more thing, guys. It should be green in after sometimes. If it not, it is not showing green here. So it should be reachability to the internet. Okay, so let me check here. I'm able to ping Google DNS or not. If not, then we need to do shutdown, no shutdown of interface. Okay. Otherwise, our recursive DNS will not work. Okay. So ping 888888. Okay, so it is not pinging. That is the reasons. Okay, so what I need to do, I will try to bounce this interface. So A5 DNS will communicate to the Google DNS and Open DNS via internet. Okay, that is the reason we should at least need internet IP address, sorry, internet reachability. Otherwise, this concept will not work. Okay, so what I will do, go to the config terminals, interface, which interface is 0 by 0 by 0, and we can do shutdown. This is lab environment, guys. So these things happen in the lab, but in production, we don't need to worry about it. Just shut down and then no shut. And then we'll try to again ping. Oh, sorry. So IP interface brief 137.1.1.10 and put okay. Let me do interface fast Ethernet 0 by 0 address DHCP. Yeah. Now it should be pingable. Let me ping again. Okay, now it is pingable. So now we have sometimes happen in the lab, guys, so don't worry about it. So because if you see now it is full hour green, means now our F5P is easily communicating to the 888 and 999. Okay. So now it is green. If it is red, we can't proceed further. Okay. So now we have created pool also. Now we need to create cache profile. So that F5 is going to be maintain the cache. So we need to go on the how we can create the cache, guys. DNS cache and cache list. Come to the DNS and then cache and cache list. If you come here, it is already there. Let me delete it. I'm going to create for you guys, and we can create here. We can give name here DNS cache. You can give any name. Or maybe give like demo cache. Here we need to select transparent. Very, very important. Why I've selected transparent? Because A5 is just working here as a transparent. A5 is facing the detail from the Google DNS and Open DNS server. So I know, like you guys already know the concept of transparent. Transparent means I am work as a whatever details I am getting sent to the you, getting from you, sent to the another people. So I'm just working as a transparent in the middle. Okay. Keep all the setting as it is, and we can create finish. So let me verify the steps. Transparent, rest of the setting, yeah, fine. So I'm explaining all the step, including the mechanism, like why we are creating that. Okay. So we have created cache, then we need to create log publisher. So how we can create log publisher? We need to come systems, then logs here, logs and configuration, and then log publishers. So we have created logs. Let me delete this. Delete it so that I can create for you guys. Like create here. And you can give a name here. That will be local syslog because we are seeing the log locally. We don't have any external login server here. We can give here DNS logger and insert DNS log, destination, local syslog, full, okay, and then finish. So we don't need to do any more things, okay? Just need to create like that. Finish. So we have created log publisher also. Now we need to create DNS log. How you can create DNS log? Come to the here DNS listener and profile. No, GSLV I think. Let me show the steps. DNS delivery profile, then other. So we need to go DNS delivery, then profile, then other. Here is a DNS log. Okay. We need to create here. You can give here, for example, DNS. DNS logger. I think we have given the name DNS logger. Let's see if we give the error, then we can change it. So see guys, whatever log publisher you have created, now it is pop up here. See, we can give here name other. For example, DNS logger -1. So whatever created, now it is showing here. Just try to enable all the things. Okay. Finish. So we have created DNS logger. Now it is very, very important to create DNS profile. So in this profile generally we call on the listener. Listener means virtual IP that will act as a DNS server for the machine. Okay, so how we can create a DNS delivery profile and then DNS, and we can create and give this name, or it depends upon you like which name you are giving. Okay. Okay, so come to the DNS delivery profiles DNS. Now we need to create profile here, guys. Create here. Let me give here DNS profile. DNS profile. And it is very, very important to enable the DNS caching here. It is disabled at the moment, so we need to enable it. So we need to follow this step to enable it. Okay. DNS cache enable. DNS cache name we have given unhandled query actions allow. This one should be allowed. It is already allowed. DNS cache name whatever we have created on the before like previous step we have selected here. And use bind server on BIG-IP disable. This should be disabled. And okay, so disable logging and reportings. Then logging and reporting we need to enable it. Enables, and whatever log profile we've created we can select here. So logging and reporting we have enables and we have selected it, then we need to click the finish. So we have created DNS profile. Now we need to create the listener, and inside listener we'll call all the things whatever created before. So how we can create listener? This is the listener. Delivery, DNS delivery listener, GTM listeners. Here we can create listener. We can give, for example, DNS listener. In a state enables, what is the IP address? I want to give IP address from this range. This interface IP address 192.168.1.126. So I'm giving from this range 192.168.1.127. We can create 1.127. I am trying to applicable for internal VLANs because that query will come from the inside PC. Inside PC you trying to access facebook.com. That is the reason I am putting to allow the internal VLAN. Maybe in your case we can allow. It depends upon your design. So I have done the design like this. So it depends upon your design how you have done in your lab setup. So I have now if anyone coming from internal to for any DNS query on this IP address 1.127, this is the by default protocols. SSL profile as it is, and we need to click here advanced services. UDP, they keep as it is, DNS profile. So whatever DNS profile we have created, we need to select here. Okay. Default pool, whatever created, we need to select here. Device persistence, keep as it is. And let me just verify the steps. Okay, so we have created listener, state enable in going the advanced. We have given the IP address as per our designs. VLAN we have enabled. Source address we can keep here can keep here advanced, and source address we can keep here automap, and address translation we can enable, port, route address, everything. So you need to enable this one. You need to enable, and auto last stop default and last stop pool none. And we have configured we have added the profile pool and we finish it. So we have created the listener. Okay, and now we need to do last things here to set the TTL's values. Okay, so like how many times, like till how many times F5 is going to maintain the record of that URL. So how we can do the DNS settings and cache. Come to the DNS setting and cache. So we have already done it, so don't need to worry about it. So for 3 there's many seconds. So it is going to be maintain the entry of any URLs IP till this times, maximum this time. Okay, and the buffer size is this. Okay, after that is going to flush it. Click on the update. Okay, now if you come to this PC, and meanwhile I want to show the D command, so I want to show the F5 itself. So let me log into the F5 here, 192.168.137.108, because D command is default run on the Linux, but Windows, for that we need to install it. Okay. Let me check the IP config. Okay, so 126 IP config /all. What is DNS IP? 191.127. So let me do NS lookup. NS lookup www.facebook.com. See, I'm getting the IP address facebook.com. So how it is when this request go to the F5, F5 is sent that to the pool 8888.999, get the details of IP address. F5 is going to maintain its cache and give it to me. This is here F5 is working as a recursive DNS server. Okay, we can give to this particular server also. NS lookup server 192.168.1.127. What is the meaning of this command? I have run the NS lookup and then I'm typing server, means whatever query I'm going to do now, it is going to be taken from the 1.127. Means whatever request I am doing, facebook.com IP address, youtube.com IP address, it is going to be fetched from the who is going to provide 1.127. So same things we can do in the production also. If you want to get the IP address from the specific server, run the NS lookup, go on the server, that IP. For example, if you want to get the IP from Google DNS, run the command NS lookup server 888 and then try to hit your query like facebook.com, youtube.com. Okay. So I'm trying here www.facebook.com. Right. So I'm getting the IP address, but it is saying non-authoritative. It is which is expected because F5 is not acting authoritative. It is taking the details from someone else, some open server. Same thing we can do www.youtube.com. I'm getting the IP address. There are so many IP addresses of the youtube.com. Same things we can do in the here also because D command will run. D run on the by default on the Linux. So we are on the bash shell. Bash means we can run all the Linux command. Dig. I'm asking 192.168.1.127. I need IP address of www.facebook.com. See, let me increase the size so that you guys can have visibility. Let me run the command again. See, what is the difference between dig and NS lookup? In dig, we are able to see like how many times. See, F5 is sending the details in 1 milliseconds. Okay, so this is the beauty. Okay, so I have requested to this server. This is a VIP which is configured as a listener or a pipe DNS. I'm requesting I need IP at facebook.com, sending in 1 milliseconds. So because it's mentioned is cache, and if do against 1 milliseconds, mean after something, see, sometimes increase, decrease, okay, because we are doing on the F5 itself, okay. But in company we do from the on the machine and all. So in this is the work of dig. In dig we can see more details like how many query we have done, answer, authoritative, additionals, how many query times it is taken. So these things we can do in the with the help of dig commands. So dig is by default enabled in the Linux. Let me know if you guys any question till now.
Okay, this traffic, can we see it in the F5 as a in the GUI?
Yes, let's see. I never tried that, but we have configured for that itself. So come to the systems. Or how you can do the with the statistics, module statistics, DNS, and then we'll try to see that. Let's see. DNS and listeners. So I can see listener is up here, and there are so many details here. Traffic in, out, and
Click on the details and view the same one. Yeah, yeah.
yes, we have some more details here. So how many traffic are in and out. We can see some on the way also. Let me do data format. Come to the module statistics, DNS, and cache. So one cache it is maintained. Stream cache. I want a statistics. Total query these, total response these, answer locally. Oh, so see, 12 times it is answer locally. Means from the cache. Yeah, so this is how we can do some deep dive delivery DNS zones. Okay, so zone concept is not at the moment. We'll see later. So DNS and then cache we have seen, delivery, listener, and pool. Okay, let me try to see here. So we have seen so many traffic. Okay, so F5 is sending the traffic to the pool like 888.999, and we have configured round robins. It will send in a round robin manner. Okay, so this is how we can do and check. One more thing I want to check here. Come to the systems, logs, and GSLV. It will see after tomorrow session. So we'll see GSLV related things here. This is the related GSLV.
Okay, it's yeah, it's fine.
Yeah,
We need to look at more while
yeah.
another lab.
Log publishers, teams, yeah, on that profile we can see the statistics, and we can show here, for example, if we do capture here, for example, if you do capture here, that will be good things for your answers 1.1, and then we can wrap up our session for today. And let me log in this, and we can do counts. See, 1.109. This is your client PC. It is requesting 1.1 divided the IP address youtube.com. And then 1.27 is going to be our, if we click here, query answers, see, it is going to provide the IP address youtube.com, right? So instead of that, we can do varchar. It is very good things and it is quite visible. So
This is the best way to troubleshoot.
yeah, troubleshoot, yeah. This is the best way to troubleshoot, like how which request is done by his client and how our DNS server is sending. This is the query. I need IP address of www.youtube.com. It is type A record means that type A record means this app being binding to the IP address. So I need IP address of www.youtube.com. In answer, it is going to provide that. So this is how we can do deep dive. And so that's it for today, guys. I hope this has been informative for you guys. And at least you learned some things related to A5 DNS. And once you do brush up, it will give you more confidence.
Okay, that's great. So we learned something. That's as you said, yeah, it's good. So hopefully tomorrow we'll continue again. Okay.